So in the 3.3 lesson, we are continuing to talk about key features of functions, and we're trying to identify things like intercepts, intervals where we're increasing and decreasing, maximum minimums, symmetries, domain and range, and end behavior. So there's two new words that we haven't talked about in here, which are symmetries and end behavior. Symmetries is like if I could fold, when I'm folding clothes, where that line is where things match up and reflect equally on either side, where things are symmetrical. And end behavior is if I look at really, really, really big numbers, where does it end up? Does it end up, how does the end result of a really, really large number look in the equation? So, for example, number one, we want to identify, first let's start with intercepts. And I can see an intercept right here, and what looks like an intercept here, but it's an open circle, so it's not included, so I'm not going to include that as an intercept, but I do have an intercept right there, which is my intercept, which would be a y-intercept of 0, 3, because it's an x, y coordinate, and so my y-intercept is at 0, 3. Next, I'm going to look at where it's decreasing and where it's increasing. Well, where it's increasing is when the graph is moving upwards from left to right, which it is here, and we write that using our x values. And where does it start? Well, it starts here at -3, and since it's a closed dot, I'm going to use a bracket, and it ends at what looks like 1. And I'm going to use a closed bracket because it's a closed circle. It's a filled-in circle. Now it's decreasing. Now it's decreasing when the graph is going down from left to right, and it starts where the increasing left off, and it ends here at 4, but that's an open circle, so I'm going to use a parentheses. Next, I'm going to look for maximums and minimums. Well, there's a maximum up here. Right here is a max, and here's a min. And even though this is a open circle, I'm still going to call it my minimum for now. And my maximum, though, for sure, we can write that, is 1, 4. And I'm running this in order pair, an xy pair. The x coordinates is 1, and the y coordinate is 4, because this is my x, and this is my y coordinate. And then my minimum would be at 4, 0. Next, we have domain and range. Domain is our x's, so horizontally. So what's my leftmost point? Well, it is -3. And it goes to 4, and 4 is an open circle, so use a parentheses. And notice it's kind of like the starting point of the increasing and the end point of the decreasing, because our increasing and decreasing intervals kind of combine to make our domain. Our range is our change in our y's, or what our lowest to our greatest point is, and our lowest point is here at our minimum, and we look at the y value. Well, at this point, our y value is 0, and it's an open circle, so I'm going to use a parentheses. And our maximum point is up here at 4, my y value 4, so my range is 4. So, and I'm going to use a bracket here because it's a closed dot. Now, end behavior. Now, end behavior is if this was continuing on forever in a certain direction, which it isn't because there's dots, doesn't really have any end behavior. But if we look over here at number 2, these arrows go on forever, and so we could say end behavior, well, it's going forever and ever and ever on to infinity. And that's kind of what the idea is some of these go on forever and some of them don't. The other question is, that was a new one, is does this represent a function? And there's something called the vertical line test, which is where you take a ruler, and as if you can take your ruler and move it over a graph, and at no point the ruler is touching the graph at more than one location, then it's a function. So if you look here at number 2, as I move the ruler over, it's touching the graph at 2 locations. It's touching right here and right here. It's also touching, if I move it again, it's touching right here, right here. And as long as that, if it happens once, it means it's not a function. The idea is a function, for every input, there is one output. So a function is every input has only one output. Kind of like in a vending machine, when you press a button for a soda candy bar, you're only going to get one item. If you get 2 items, then your machine's broken. And so that's the idea here. If you press a button, every input, you get one output. So vertical line test allows us to check that. If we have a vertical line and it intersects at more than one location, then it is not a function. Like for example 2, it's not a function. So this one's not a function. But we can still answer these maximum minimums, domain range, increasing, decreasing. We can still do that. And so I want you to do that. On the back page, page 12, one of the things it asks you is to determine x and y intercepts. So an x-intercept is when it always looks like this. We have an x number here, so it could be 1, 2, 3, 4, negative 20, a half, anything like that. And the y value is always 0. And that's because it's on the x-axis. A y-intercept always has 0 in the x-coordinate and then has a y value in the y-coordinate location. So that's one way we can look on the table. Here is our x-coordinate, and this is f of x is the same thing as our y-coordinate. So if you're looking for an x-intercept, you're looking for a 0 in the y to find your x-intercept, and if you're looking for a y-intercept, you're looking for a 0 in the x-coordinate to find your ordered pair. If you have any questions on how to identify these key features, make sure you take note of them so that when I come back on Wednesday, we can have meaningful discussion. Now, as far as the 3.3 ready, which I am assigning as homework, I'm asking you to evaluate these linear functions and to fill out the table using it. Now, there's more than one way of doing this. One of the first ways to do it is by plugging in x values into our function. So, for example, I'm going to start with number 1, and I'm going to use, you could start with 0, but I'm just going to use this location 2 when x is 2 just for an example. And so it'd be f of 2, because x is equal to 2, is equal to 3, and so x is 2. So instead of an x there, it's now going to be a 2 minus 5. And it's 3 times 2, so I'm going to rewrite this as f of 2 is equal to 3 times 2, which is 6, minus 5. Well, f of 2, well, 6 minus 5 is 1, so I have 1 here. Something else you could notice is that this is in slope-intercept form, and that's my y-intercept, and x is 0 here, and that's where my y-intercept, my starting point is. So I could know that that's negative 5 there. And the 3 is my growth pattern, so I could also just go from there and just, 3 is my growth pattern, I'm starting at negative 5. Well, if I'm going 3 from negative 5, I will be at negative 2 next. Add 3 to 2, negative 2, and I get 1. Add 3 again, I'm at 4. Add 3 again, I'm at 7. And so you could do it by plugging in values in for x or by noticing the growth pattern and the starting point for each of these. Now, notice on 2 and these problems here, they don't give you x values. You can pick what values you want to be for that. And then notice here it says, and for number 1, the other part is once you have filled out your table, then you have to identify where these two functions would intersect. So on this problem here, they do not give you the points to check, so you might have to trial and error and try more points if the points you select don't match. I would encourage you to start with 0 and go from there. If you have questions, please take note of them so we can talk about them on Wednesday.